Alright, example 2, considering the situation of assigning 4 deliveries to 4 courier firms here, and each firm will be taking 1 delivery, and we are aiming to minimize the total cost that we spend for all these courier firms to complete all the 4 deliveries. So use Hungarian algorithm to determine the optimum allocation. So we are going to use whatever that we have learned, but we are not going to put it in step by step to see how should we answer it in a real question. All right, so the first step, if you can recall, we need to rewrite all this information and represent all this information by using a matrix form first. All right, so let's try to transfer all our information here. So I'm going to fast forward for this part. All right, so after we have write down in a matrix form, then now we can start our steps here. So remember, the first one, we need to do our row reduction first. So find out what is the smallest number in each row, then we are using we are subtracting the smallest number from the other element from the same row. So 250, 100, and 140, 120. So the smallest number is 100. So minus, okay, minus, minus, and minus. All right, second row, smallest number is 110. So each number minus of 110. So 11000 40 and also 0. So again, please try to practice your mental calculations so you are not taking too much time when you are not familiar with mental calculation when you are doing your final exam. So 220, 90, 160, 130. So the smallest number here is 90. So when you minus 130, 0, 70, and 40. So last row, we have 120, the smallest one. So 140, 20, 50, and also 0. All right, so after you finish your row reduction, then now we need to do our column reduction. So find the smallest number in each column, then you use the other element to, subtract the smallest number from the other element from the same row. So the smallest number is 110, so 150 minus 110, 110 minus 110, 130 minus 110, 140 minus 110. So the smallest number in your second column is already 0, so 0, 0, 0, 20. All right, because 20 minus 0, you are going to get 20 as well, right? So 40, 40, 70, 50, smallest number is 40. So 0, 0, 30, and 50 minus 40, that's 10. Right, so for last row, the smallest number is 0. So everything minus 0, you get back the original number. Okay, so after you have found this out, then now you can continue with your next step. So the next step is you need to cover the 0 by using the least number of line and to check that the number of line that you need, is it the same with the number of row or the number of column here. So you can see this is a 4 times 4 matrix. So later after you find out the number of line that you use to cover should be exactly equals to 4. Okay, so now let's try to do that. So you can try to use your highlighter to do that. That will make your letter still obvious after you try to, cross it off. All right, so we are going to use the least number. So that's why we started off with the line where you can cross as much as 0 that you can. So for example, I'm going to draw it here so that you can cross off 40. All right, then after that, the second, maybe I want to cross here, then you can cross the other 20 as well. So you can see that as after you have crossed off these 2 row, right, you realize that there's 2 0 left, and no matter how you are going to draw it, you need 2 more lines. So that's why it just depends on you whether you want to draw a horizontal line again or you just want to do it like this. So that's totally fine. But at the end of the day, the least number of line that you need to cover all the 0 will be 4 lines. All right, so after you cover everything, then you realize there's no more 0 left. All the 0 has been covered by using 4 line. So that's why in this case, the number of line and the number of row that you are having is the same already, which is the 4 equals to 4. So number of line, all right, is equal to the number of row. Okay, so which is 4 equals to 4. So that's why the Hungarian algorithm, you can stop it here. So after you have find this out, then we can try to determine the 0 lah. Perhaps you can try to copy one more time. So yeah, it's not so messy. Alright, so after you have find this out, then now we can try to identify our zero. So remember, only one zero is circled in each row and each column because you want to make sure that you are doing a one-to-one matching. So there's no one courier firm is going to take two delivery and all the delivery must be having one courier firm to actually have it to transport. Okay, so let's try to identify the zero that you will be picking. So in this case, then let's try to identify those with only one zero. So for example, the last row here, you have only one zero. So that's why courier D must be taking your delivery 4 already. So continue on. The other one that you can try to do is, oh yeah, so for this column as well, you only have one zero. So this is obviously the zero that you are going to pick. So now you can see that you only left with, yeah, so for the third row, you also only have one zero. So this is the one. So the one that without any circle will be this column, and you left with only the first row that you do not have any zero circle. So that's why that's going to be this one. Okay, so now you can try to check all this out. Then after that, for the last one, if you think that you need to write down, then you can always write it down. If no, then you can straight away take your number from the above already. So which means by looking at this, then you know that Courier firm A is going to do delivery 3. Courier firm B is going to do your delivery 1. Courier firm C is going to do your delivery 2. Courier firm D is going to do delivery 4. If you think that you can't read it like this, then you can just write down based on whatever that you have put in here. Then you write down A, B, C, D, 1, 2, 3, 4. Then you'll be able to identify which one that you are choosing. Alright, so after you find this out, then now we need to find out what is the total cost that you need, what is the minimum total cost that you need. Alright, so in this case, the 4 number here, so you can try to circle out as well. So which means just now is this number, this one, and also this one. Alright, so 140, 220, 90, and also 120. Alright, so add them up together, then the cost that you need to get all this delivery completed is $570. Alright, so that's the idea here. So by by looking at the situation, then you can try to see as well, is that something that makes sense lah. So for example, you can try to check, okay, for example, delivery 1 here, this is the smallest one, so it's something that's logical. This one is also the smallest one. So by looking at this, then you can see that, although this is not the minimum one, but then it's somewhere in the middle, and the difference between all the number is only like 10 greater or 10 smaller. So that's why it's something that is a logical one. So imagine if you've taken the other number, then you can imagine you might be having the other combination that give you the smallest number. So after you after you finish and after you get all the answer right, then you can obviously try and check and see whether your answer is a reasonable one or not. So yeah, let me try to use this to give you an idea. Okay, for example, right, so you realize that for this 3 number is something that is logical, but then you can imagine if let's say delivery 4, you are choosing the minimum one, right? So then which means that courier firm B is taking delivery 4. For this case, you cannot choose 220 again. So maybe you say that, or maybe here you can choose the 220 here. Then after that, which means courier firm C cannot do delivery 2 already lor. Then maybe you can say that, or maybe courier A can do delivery 2. And then but when you reach here, then you realize that now you cannot pick courier A, B, C already, then you got to choose D. But then compared to delivery 4, which is not the minimum just now, which is going to be like 10 more than the minimum, now by using courier firm D to do delivery 3, eventually you have 30 more than your minimum already. So that's why this combination will give you a total cost that is greater than the previous one. So by using all this logical thinking, then you can try to check whether your answer is something that's logical or correct one or not. Alright, so that's the answer for this question, $570. Okay, so I hope that now you can remember all this step. So row reduction, column reduction, cover all the zero. If after you cover all the zero, the number of line that you use to cover all the zero is equal to the number of row, then you can, that's the end for your algorithm, then you can identify 1 0 for each column and each row, then that will be your solution. Then you can find out what is your minimum total cost. Okay, so now let's try to look at the next example. Alright, let's look at example 3. A company has to allocate three tasks, task 1, 2, 3, that has to be matched to three employees A, B, and C. So each of the employee here has a time recorded for each task, and the time here is shown in minutes. So use Hungarian algorithm to determine the optimum allocation to minimize the total time that needed for all the tasks. All right. So this is similar with the situation that I mentioned just now. So you have a group works and you have different people in your group that you want to assign the different tasks to different people, so to minimize the effort, to minimize the time that you need to complete all the tasks here. All right, so first thing, same thing, let's try to write it in a matrix form. All right, so similarly, the first step that we need to do is to do the row reduction. So smallest number is 5, so that's why 3, 5, 12. Smallest number is 7, so 4, 0, 11. Smallest number is 8, so 1, 0, 7. All right, so after we have carried out the row reduction, then we'll be continue with the column reduction. Sorry, the space is a bit small because I do the space here. Okay, so the column reduction, then we have the smallest number for the first column is 1. So that's why we have 2, 3, and 0. Then after that, the next one we have 0, 0, 0. And the last one we have 7, the smallest number. So 5, 4, and 0. All right. So by looking at this situation, then now we can proceed with our step 4, which is to cover the 0 by using the least number of line. Okay, so in this case, you realize that if you were to use the least number of line to cover all the 0, then what you will be doing is maybe this will be your first line, then this will be your second line. All right, so you realize that the least number of line that you need to cover all the 0 here is only 2. So, but then this is a 3 times 3 matrix, am I right? So that's why you realize that in this case, right, the number of lines that you are having here is not equal to the number of row that you are having, because you have 3 row or you have 3 column, but the number of line that you use to cover 0 is only 2. So that's why in this case, we will need to do some adjustment. Then we can only proceed with our Hungarian algorithm to identify our solution here. So number of line is 2 and 2 is not equals to 3. So that's why this is the part where for the situation where you encounter like this, in a case where a row and the column reduction does not result the same number of line as that is in a row, then we need to do some adjustment. Okay, so in this case is that the number of lines that you have is less than the number of row lah. So normally that would be the case. So in some cases, then if let's say you have 4 times 4 matrix, then if let's say the number of lines that you need to cover the 0 is only 3, then you also need to do this adjustment. Okay, so how can we do this adjustment? So there are two alternatives that you can try to do. So the first thing, I will try to explain it by using a 2 steps approach. Then after you understand how this thing works, then you can try to use this alternative, which is a combined step for the adjustment here. Okay, so what we try to do here is the reason being for why we are getting like only 2 lines cover is that the number that we are having over here is all the small lines, it's all the smaller number, and after your reduction that actually give you all the 0. So that's why what we try to do is we want to bring up the small number to make it slightly higher, so that is something that's comparable to other number. Okay, so that's why when we try to do the adjustment, what we need to do is the first thing, find out what is the smallest number among the uncovered number. So you can see in this case, right, by looking at this matrix, what is the smallest number among the uncovered number? So 2, 3, 4, and 5 are all your uncovered number, right? And the smallest number that you have is 2. Is that okay? So what we need to do next is add the smallest number to every covered number. So the numbers that are covered twice can have this number added twice. Okay, so imagine now, after we try to do this, right, then what will be happen is we are bringing all this number that is covered, we are trying to bring it slightly higher, so that is something that we can, after we try to do reduction, then you will be able to get more 0 later after the matrix reduction. Okay, so let us try to do this. Okay, so the smallest number is 2, and we are now going to add in all the number that you cover here. So remember, this is only one example where you have all the 0 for all the covered part. In some cases, you might have no 0, so which means maybe this is 1 and then 2, you still need to add 2 lah. The idea is like that. So later in the fourth example, we'll be looking at those situations. Okay, so add the smallest number to every covered number. So which means all the uncovered number will remain the same. So you can just write down the uncovered number first. Alright, so the smallest number among the uncovered number is 2. You are going to add 2 to every covered number. So which means that all the 0, 0, 0, 0, 0 here will become 2. So you realize that this 0 is covered twice. Am I right? So this vertical line and this horizontal line, they both passes through this place. So that's why the number that are covered twice will have this number added twice as well. So that's why 0 plus 2, 0 plus 2, 0 plus 2, 0 plus 2. And this is the place where the line intersect and you have two lines cover this place, right? So that's why you'll be added twice. So that's why plus 2 plus 2. So that's why you can get 4. So this is the thing that you have after you do your first step of adjustment. Is that all right? So it means find the smallest number among the uncovered number. You are going to add the smallest number to every covered number, and the number that cover 2 times, then you will need to add twice lah onto this specific number. Okay, then later what we need to do is we will continue it with matrix reduction. So just now we already have row reduction and column reduction. So matrix reduction meaning that you are going to look at what is the smallest number in the matrix, subtract it from every element in the matrix. Okay, so which means that by looking at this matrix, the smallest number that you are having is 2. So you are going to subtract 2 from every number inside this matrix. All right, so let's try to do it. Okay, so 2 minus 2, 2 minus 2, and 5 minus 2, that you get 0, 0, 3. So 3 minus 2, you get 1, 2 minus 2, that's 0, 4 minus 2, that's 2. 2 minus 2, that's 0, 4 minus 2, that's 2, 2 minus 2, that's 0. Alright, so the smallest number is 2. You are going to use all the number here to minus 2, then you can get here. Okay, so now what you need to do here is to continue again by checking the covering 0. Okay, but before that, so this is the alternative here. So you can realize that there's 2 steps that you need to do for adjustment. The first one is find out the smallest number, add it to the covered number, right? Then the second step is you try to do matrix reduction. So now we try to see whether we can try to combine these 2 steps into one or not. So this is the alternative here. Okay, so what you can try to do is you try to realize, right, this is my original matrix. My original, which means that before I try to do adjustment. Okay, when I try to compare to this one, let me try to write down here. Maybe that's easier for my explanation. So just now we have 2, 0, 5, and then 3, 0, 4, and 0, 0, 0. Okay, so this is the one before we do our adjustment. So which means I'm writing down this one. All right, so by looking at this, right, now you can realize that is there any shortcut? Is there any alternative that we can try to combine the 2 steps that we did, so that we do not need to do it in 2 steps, but 1 step we can try to do that? Okay, so one thing that you can realize is that for all this value, right, the value here, actually there's no change. Am I right? Compared to the value here. Okay, then after that, what happened to all the uncovered number here? So compared to the previous one, you are minusing 2 from each of this number. You realize, right? So 2 minus 2, you get 0. 3 minus 2, you get 1. 5 minus 2, you get 3. 4 minus 2, you get 2. So that's why the smallest number that you have for the uncovered one is 2. So just now we cover it like this, right? So the smallest number that we cover one is 2 here. So we can try to subtract the smallest number from all the uncovered number. And then this part from 0, it become 2 now. So why does it become 2? Because you add the value to the smallest uncovered number. Okay, so let me try to repeat it again. So I will try to write my original one here. Okay, so just now we have this place covered already, right? Okay, so if we try to combine the two steps that we did just now, what you can try to do is find the smallest number among the uncovered number, which is the same with the previous one. The smallest number here is 2. Okay, subtract this value from all the uncovered numbers. So which means that 2, 3, 5, and 4, you are going to subtract it by 2. So which is the smallest number here. So that's why you get 0, 1, and then 3 and 2. Alright, subtract the smallest value among the uncovered number and subtract this value from all the uncovered number. Okay, so and then add this value to the number that is covered twice. So this is the only number that is covered twice. So 0, you add the smallest number among the uncovered number just now, which is 2. So the rest 1 kept the same. Okay, so you realize that after you combine this into one step, then you get exactly the same answer. So you do not need to do the two step just now. So just try to do this. So find the smallest value among the uncovered number, subtract the value from the uncovered number, added the value to the number that covered twice, then the other number remained the same. Alright, so after you do the adjustment, then you will be checking again by covering all the 0 by the least number of the line again. So which means in this case, you realize that how many lines that you need to cover all the 0 here. So you have the first one, you want to cover the first 2 0 here maybe. Alright, then maybe we cover the 2 0 here. Then you realize that there's one remaining, right? So the least number of lines that you need to cover all the 0 here will be 3 lines. So now 3 line is equal to the number of row that you are having here. So that's why the process is complete. So in the case where if let's say after you do the adjustment and the number of line and the number of row is still not equal to each other, then you need to repeat the adjustment step again. So it means find out the smallest number among the uncovered numbers, subtract the number from all the uncovered number and add the value to the number that is covered twice. Then you just repeat again until you get your number of lines that you use to cover the 0 is equal to the number of rows, then only you can stop. Alright, so that's the idea here. So since we already get 3 here, which means the number of line and the number of row here is the same. So now only we can stop here, then we try to find out our solution here. Okay, so let me just write down. Alright, so we have 0, 0, 3, 1, 0, 2, and also 0, 2, 0. Alright, so again, 1 0 from each column and 1 0 from each row. So in this case, then let's try to identify. So we have, for the second row, we only have 1 0. For the last column here, only 1 0. Yeah, so then this is the one. Okay, so if you need to, then you can write down as well. So just now we are looking at, this is A, B, C, different employee, and task 1, task 2, and task 3. So which means to find out the optimum allocation, then employee A will be doing task 1, employee B will be doing task 2, employee C will be doing task 3. And the total time that they need, okay, will be equal to, so you need to go back here. So which means just now is this number, this, and this. Alright, so let's add them up together. So 8, 7, and 15. Okay, and the question is given in minutes, so that's why in total you need 30 minutes to complete. Okay, so same thing. You can always go back to the question and then check whether this answer is a logical one or not. Okay, I mean, this is not a very difficult one since you only have a 3 times 3 situation, right? So you realize that, okay, so if you think that maybe the 7 here is not good and you want to pick here. So if let's say after you pick this, then which means that you cannot choose A for task 1 already, right? So maybe you say that, okay, 9 is not bad, then you can try to choose this. So if let's say the employee C is doing task 1, then he cannot do task 3. So now this is the one that you will be assigning for task 3. So you realize that for task 1, now you'll be increased 1. So even though you minus 2 in task 2, but for task 3, you increase 3. So that's why at the end of the day, you will have a total of 2 minutes extra if you are choosing the one that you are picking now in green color. So that's why the orange color one will be a better alternative that is going to give you the minimum time. Alright, so that's the idea for this question, and we are going to repeat the last example again, so to revise again for the adjustment process. Alright, so let's look at example 4. Alright, example 4. Four workers A, B, C, D all provide codes for jobs 1, 2, 3, and 4. So their codes with the cost here is shown in the table here. So determine the best allocation for the workers to minimize the total cost, and you need to find the total cost. Alright, so we are going to use Hungarian algorithm to help us to solve this question. So first step, we need to write our matrix form. So I hope that by using this last example, you'll be able to see the flow for all your steps that you need to do for Hungarian algorithm. Then you'll be having a better idea on, putting everything into one question. All right, so let's try to do that. So first case, write it in the matrix form. All right, next step, row reduction. So checking out the smallest number in each row, then subtract the number from all the elements under the same row. So first row, smallest number is 15. So 0, 9, 35, 6. All right, second row, smallest number is 18. Third row, smallest number 13. Last row, smallest number is 10. Alright, then you should be able to get this matrix after the row reduction. Then let's continue with the next one, which is doing the column reduction. So for the first row, the smallest number is 0. So that's why 0, 6, 15, and 0. Second column, smallest number is also 0. So all the number remains the same. So next column, the smallest number is 1. So 34, 0, 16, and also 6. So last column, the smallest number here is 2. So that's why 4, 0, and then 7 and 1. Okay, so after we carry out the row reduction and the column reduction, then the next thing that we need to do is to find out how many 0 that we need to cover, right? How many 0 we can cover. So in this case, then you can try it out. For example, I want to cover the 3 0 here. Alright, then you realize that you only need 2 more lines, then you can get everything covered already. So this will be your idea here. So that's why you realize that in this case, the number of line is not equal to your number of row here, which in this case, 3 is not equal to 4. So if let's say this is the case, then you will need to do your adjustment. Okay, then after that, we will continue by doing our adjustment here. So let me try to continue here. Alright, so remember, look at all the uncovered number, then find out the smallest number. So in this case, the smallest number for the uncovered number is 1. So you are going to subtract 1 from all the uncovered numbers. So that's why this will become 33. Then this will become 3. And then 15, 6, and 5, and 0. Okay, then now remember the smallest value need to be added to the element that cover twice. So this 2 number is the one that cover more than twice. So which means 6 is going to be plus 1, so that's why 7. 0 is going to plus 1 as well, so that's why 1. Alright, and all the number remain the same. So 0, 9, 0, 0, and then 15, 0, 0, 8. Okay, I hope the steps here is clear. So look at the uncovered number. The smallest number is 1. Subtract 1 from all the uncovered number. Then after that, add 1 to the number that you cover more than once. So which means the 6 here and the 0 here. Then all the other number remains the same. Okay, so I'm not sure that whether you have this question. If let's say, because you can imagine, right, what we are trying to do in this step is just to use the least number of line to cover your 0. So which means that I can have the other person that use the other way of covering my 0. So for example, let me try to copy the exactly same matrix first. 0, 9, 34, and then 4. Is it 34? Am I doing anything? Oh, sorry, my mistake here. This should be 25. This is 2. Okay, 40 minus 15. My mistake. Okay, so this is 23. All right, so now let's continue. So let me try to copy everything first. Okay, suppose that everyone will draw the first line, which means it's going to be the same because we want to use the least number, right? So obviously the first line that will be able to cover as much as 0 as we can will be cover this up. Okay, but then maybe there are some people that you realize that, hey, for this part you can cover the 0 here, and then for the next 0 maybe they don't want to do a vertical one, can you do a horizontal one? The answer is yes. So when you try to continue, if even you try to do it like this, you realize that you own also using 3 lines to cover all the 0, right? And 3 is not equal to 4. So that's why you need to do your adjustment. So when you are doing your adjustment, although you are having a different matrix with your friend, but at the end of the day, the solution that you will be getting will be exactly the same as well. Okay, so let's try to continue the other part here. So this is or. Okay, so if let's say you are cover your number by using this part, then which means that the answer that you'll be having is look at all your uncovered number, the smallest number is 1 here. So that's why minus 1 from all the uncovered number. So 8, 23, and 3. Then the last row you have 7, 5, and also 0. Okay, so 6 and 13 is covered twice, or for this part is covered twice as well. So that's why you need to add the number. So 7, and then this is 15, so 16. All right, and all the other number remain the same. Okay, so now when you continue, let's try to check how many lines can we use to cover the 0 here. So if let's say you have 4 equals to 4, then which means that's the end for your algorithm. If no, then you are going to repeat the adjustment again, which means look at the uncovered number, find out the smallest number, then you subtract and add again. All right. So same thing in this case, the line that we can pick, okay, maybe you try to draw one here. So cover 2, 0. This also cover 2, 0. Then you remaining 2, right? So you imagine that no matter how you want to draw, you also need to draw at least 2 more lines. So if let's say I try to draw it like this. Okay, so for this part, same thing. I can draw one line to cover the 3, 0 here. I can draw one line to cover the 2, 0 here. Then you realize that at the end of the day, I still need 2 lines as well. So it depends on you how you want to draw it lah. But at the end of the day, you still have 4 lines. So which means in this case, then you realize that you have 4 equals to 4 already. So now you can go ahead for your final answer, okay, to choose the 0 that you can have. Okay, so let's move on. All right, I'll be just copy down or okay, 0, 9, 23, 3, 7, 1, 0, 0, 15, 0, 15, 6. All right, then the next one we have 0, 5, 0, 8, 5, 0. All right, so by looking at all these numbers, so now let's try to check. So 0 for the first line here, for second column 1, 0, for third column you also have only 1, 0, then the last one since you already picked here, so that's why that's going to be here. Okay, so which means in this case that's going to be, this is your A, B, C, D, then 1, 2, 3, 4. So that's why worker A will be doing task 1, worker B will be doing task C, worker B will be doing task 3, worker C will be doing task 2, and worker D will be doing task 4. Alright, so that's the idea here. So imagine if let's say you are using this, right, then you will get the same thing as well. So 1, 0 here, another 0, this line also have 1. For this line you also have 1, then here the last one. So you see that the circle that you are putting in the position are all the same. So whether you are using this approach and this approach, they will just give you the same answer. It's just that your matrix will be different. Depends on depends on what is the line that you use to cover your 0. Alright, so after you get the answer, then we can now find out the total cost that we have. Okay, so worker A doing job 1, that's going to be $15. Worker B doing task 3, 19. worker C doing task 2, so 13, worker D doing job 4, so 13. So when you add them up together, you get 34 plus 26. So that's going to give us $60. Alright, so that's the idea here. So I hope that you can understand the whole idea by using this approach. Okay, so same thing, you can try to circle it at the top here, then try to see whether your answer here makes sense or not. So this I'll answer. Okay, so you can see it's something that makes sense because you realize that for this row and this row is the minimum already. So for this one, I mean, it's not the minimum, but then compared to 30, 40, it's relatively small, right? So for this one, it's also not the smallest one, but compared to 24 and 28, it's considered a small one. So that's why this is a logical answer. Alright, so that's the idea here. So let me try to repeat the whole steps again. So rewrite it in matrix, row reduction, then column reduction. After you have finished off the column and row reduction, then you are going to use the least number of line to cover your zero. So there will be two cases that you will be having. So the first one is, okay, let me try to write like this then. Maybe that's easier for you to understand. Okay, so this is just a very quick summary here. So after you do the matrix, then you will move on to row reduction. So after you do row reduction, then you will be doing column reduction. So after you do column reduction, then you will be covering your zero, right? So draw using the least number of line to cover the zero. So after you use it to cover the zero, then normally there will be two cases. So the first one is you straight away can get the number of lines is equal to the number of row. Okay, then which means that you already get your solution, then you can start to circle your zero, then you'll find out your answer already lah. So basically that give you the answer. So if let's say in this case, after you cover the zero, you realize that the lines and the row, they are not equal to each other, which means that what you need to do, you need to do the adjustment. So look at the uncovered number, then you find out the smallest number, subtract it from the uncovered number and add it to the number that covered twice. Alright, so you need to do the adjustment. After you do the adjustment, then you go back again and cover the zero. So if let's say the lines and the row is the same, then you get the answer. If let's say lines and row is not the same, again, then you need to do adjustment and you repeat until you can get the number of lines and the number of row is the same, then you can get your answer. Alright, so this is the whole flow of the algorithm for Hungarian. Okay, so for today's session, we already covered the part where how to use Hungarian algorithm to solve minimum problem. And for next lesson, we are going to talk about maximum and also look at the situation where how if the matrix that you are having, right, the row and the column is not the same. Because in this case, every situation that we are looking at is that you have 3 workers then 3 tasks, you have 4 workers then 4 tasks. How if let's say you have 3 workers but you have 4 tasks, or you have 4 workers but you have 3 tasks? Alright, so those are the special cases that we'll be looking at in the next lesson. Alright, so that's it for today's lesson. Thank you.